Biosignals are defined as space, time, or space-time records of biological events, such as the electrical, chemical, and mechanical activities associated with processes like a beating heart or contracting muscle. So, the terahertz network is not sending your heartbeat into your body and pulling it back out of your body. These signals contain valuable information that can aid in understanding physiological mechanisms and may be utilized for medical diagnosis. Let's go over here to Google, and we're going to search biosignal. A biosignal is any measurable signal, electrical, chemical, mechanical, optical, generated by a living organism, reflecting its physiological state, like heartbeats, ECG, brainwaves, EEG, or muscle activity. You see, it says living organism. We are not measuring from a model, we are measuring from a body. Biosignals come from biological entities, bodies, animals, etc. Let's scroll down here and click on this link. Biosignal 2026. 19 years of these conferences internationally on systems and signals. The International Conference on Biologically Inspired Systems and Signal Processing. Now, you take a look at what you got here. Medical image acquisition. So you mean to tell me, when you go in to get an MRI, they are measuring something else, putting the MRI in your body, and then retrieving the MRI data from your body? No, they are measuring magnetic resonance imaging inside your body. EEG, they are measuring the electricity in your brain. They are not shoving a signal in your brain, measuring that same signal, and extracting that same signal. So, as you can see here, electromagnetic fields in biology and medicine, monitoring and telemetry, frequency analysis, and velvet transform. Now let's go back. Electrical biosignals, mechanical biosignals, chemical biosignals, they all come from the body. Not to mention, in order to do the protein folding and omics, you have to be able to take real-time monitoring, like remote patient monitoring, real-time signal acquisition. What does it say here? Any signal in a living organism. Inside a living organism. If they were not measuring your biosignals, they wouldn't have any models to work on. We're going to Google. How are biosignals extracted from the body? Biosignals are extracted from the human body by detecting, amplifying, and recording the electrical, physical, or chemical changes that occur during physiological processes. These signals, such as electrical potentials from the heart, ECG, or brain, EEG, and mechanical vibrations from muscle contraction, EMG, are generally captured using sensors placed on or inside the body. Methods of biosignal extraction. Non-invasive surface sensing. This is the most common, comfortable, and risk-free method, where sensors are placed on the skin surface to detect bioelectric potentials. Electrodes. Specialized electrodes are placed on the skin to detect electrical activities like EEG, ECG, and EMG. Wearable textiles. Smart clothing or fabric-integrated sensors can measure signals like heart rate, breathing rate, and skin temperature continuously. Optical sensors. Devices like PPG sensors in smartwatches shine light into the skin to detect blood volume changes in the microvascular bed, allowing for heart rate monitoring. Acoustic transducers. These detect sounds produced by the body, such as heartbeat or blood flow. Invasive implantable sensing. These methods involve placing sensors directly inside the body for more accurate, high quality, or specialized recordings. Needle electrodes. Inserted directly into muscles or nerves to capture cleaner, more specific, high frequency signals. Implantable sensors, IMS. Miniaturized sensors, often used in prosthetics, placed directly into muscle tissue to detect contraction signals. Nerve cuffs. Flexible, biocompatible wraps with embedded electrodes that are surgically placed around a nerve bundle to record neural signals. Brain arrays. Arrays of microelectrodes implanted into the motor cortex of the brain to detect neural activity for brain-computer interfaces. Signal pre-processing. Raw signals acquired from the body are often faint and noisy, requiring signal processing, including amplification, filtering, analog to digital conversion. Common examples of extracted biosignals are your heart electrical activity, your brain electrical activity, your muscle contraction signals, your eye movement signals, your skin resistance/conductance reflecting stress, and your stomach electrical activity. We're going to click on this link. Biosignals Processing 101, Feature Extraction. Imagine you're looking at a biosignal, for example, an ECG recording. Here it talks about what features you should know. Hands-on experience with Biosignals notebooks. Learn how to identify our peaks in ECG signals and how to compute heart rate series. Temporal features focus on the timing aspects of biosignals. They help us understand how events unfold over time. Statistical features. Standard deviation of normal to normal intervals. Root mean square of successive differences of normal to normal intervals. Standard deviation of successive differences, among many others. This variability can relieve stress levels, autonomic nervous system balance, and more. Special features delve into the frequency constituents of a signal. So now you can only take different types of the frequency. Morphological features, examining shape and structure. Examining shape and structure of the skull, the veins, and the arteries. Any type of signal acquisition when it comes to biological signals has multiple networks, multiple ways in order to secure the biological data. Deliver with quality service the biological data. This pronounced waveform in the ECG allows us to effectively leverage morphological features to analyze its detailed structure. Coming up, real-world examples of biosignals processing with Plex users. Now, let's go over here. In 2018, in the IEEE Journal of Translational Engineering and Health and Medicine, an open source feature extraction tool for the analysis of the peripheral physiological data, electrocardiogram, electrodermal activity, electromyogram, continuous blood pressure, and impedance cardiography are among the most commonly used. Peripheral physiological signals, biosignals, in physiological studies and healthcare applications, including health tracking, sleep quality assessment, disease early detection/diagnosis, and understanding human emotional and affective phenomena. This paper presents the development of a biosignal-specific processing tool for pre-processing and feature extraction of these physiological signals according to the state-of-the-art studies reported in scientific literature and feedback received from the field experts. Biosignals are something that is used in medicine, monitoring, and telemetry, pattern recognition, and machine learning for biosignals data, neural networks for biosignal data, multi-module speech and audio processing, and biometrics. Biosignals are something they use with biotelemetry. Let's go over here and look at this lovely image. Taxonomy of biosignals resulting from human activities captured by sensors. So they capture our gesture, facial expression, motion, respiration, eye gaze, brain activity, dermal activity, heart activity, muscle activity, speech, body noise, nonverbal articulation, and body temperature. And here they have the sensors: gyroscope, video camera, near-infrared spectroscopy, surface electrodes, magnetometer, microphone, sonograph, thermal meter, and thermal camera. They take kinematic biosignals, optical biosignals, chemical biosignals, electrical biosignals, acoustic biosignals, and thermal biosignals. We're going to go over here to YouTube and we're going to watch a video on biosignals.
Hello viewers and welcome. This is your host Mohammed Arifin, and in this video I'm going to talk about biosignals. A lot of people have asked me the same set of questions over the past couple of months, like what are biosignals, or why and how do you use it, and what kind of biosignals have you used for your project. So without any further ado, let's jump right into it. So first of all, what are biosignals? Biosignals are physiological signals emitted by biological beings, which can be measured through electrical probes. In easier words, biosignals are teeny tiny electrical signals emitted by our body when we flex our muscles, move our eyes, or even when we think or sleep. So we, as human beings, produce thousands of biosignals every second. You can use special kind of amplifiers called instrumentation amplifiers to amplify the signals and use it for human-computer interaction. The most common biosignals are electroencephalogram signals, or EEG signals, electrocardiogram signals, that's your heart signals, electromyogram signals, that's your muscle flex and movement signals, and electroculography, which is your eye signals when you move your eye left to right or move it around or up and down, etc. So I'm sure you have seen these signals around, maybe in a hospital when the doctor puts probes in a patient's chest, and you can see the heart signal. That is electrocardiogram signal. In the next couple of slides, we're going to talk more about these signals. We're not going to dive deep into the details, we're just going to cover the very basics in this video. First, we're going to talk about EEG signals. So what are EEG signals? EEG signals are electrical signals produced along your scalp. When we think, our brain sends ionic currents within the neurons, and with the help of electrical probes, we can measure the potential difference and use it to detect brain activities. The signal in the figure was captured during our data collection for focusing and defocusing. If you pay attention, you can actually see in the left-hand side the amplitude is larger when your eyes are closed versus the right-hand side where the amplitude is much smaller when your eyes are open. So you can clearly see the distinction between open eyes and closed eyes. Now you can run the data through a machine learning algorithm to classify these two states. Now let's talk a little bit about EMG signals. Electromyogram or EMG signals are electrical potentials produced by our skeletal muscles like our bicep, tricep, or forearm muscles. When we flex these muscles, or a muscle contraction happens, there are sudden increase in amplitude of the signals which can be collected and classified. We can even measure muscle fatigues through EMG signals. When our muscles get fatigued, the amplitudes of the signals get even larger, which could be identified and collected. In the figure, the spikes are EMG signals every time you grind your teeth. Now a little about EOG signals. Electrooculography signals, or EOG signals, are produced by our eye movements. When we move our eyes, the retina and cornea creates an electrical dipole which emits electrical signals. These signals can be measured using electrical probes and used for human-computer interaction. So people have asked me, what kind of biosignals have you used for your project and what do they do? For this project, we collected EOG and EEG signals from human eye movements and brain activities to use them to interact with your mobile device. You would be able to control your Android phone, a tablet, or play games on your device just by moving your eyes or thinking about it. You can also collect raw biosignals using our Arduino shields and explore machine learning. Thank you for watching the video, and if you find it useful, please rate it up and subscribe to our channel. More video tutorials can be found at optivity.net. I will put the links in the video description below. If you have any questions or comments, please leave it in the comment section. I will try to answer all your questions as soon as possible. Again, thank you for watching and have a great one.